so when we ask for the domain, what it really means is what values can x be for that function. So like if I were to solve for x, what all values could it equal? Some functions have restrictions for values of x that would make it either undefined or the outputs to be not real numbers. Okay, so what we want to think about is in what situation do we get undefined numbers? There's like one thing that's not allowed to happen, specifically with a fraction. What's not allowed to happen in a fraction? Tyler? Yeah, you can't have a zero at the bottom of the fraction, right? That's an undefined value. So that's one of the restrictions that we're going to be using. And then the other one is what situations do we get imaginary numbers? With what? Square roots of negative numbers, right? So that's another situation where we would get something that is not real. Okay, so those are going to be the two that we're really focusing on. If it has a fraction, what values make that denominator zero? That's going to be what we cannot use in our domain. If we have a square root, what values would make that negative? That would be what we cannot have in a domain. Okay? Is everybody good? All right. So we have this little chart we're going to kind of fill in. You have three functions, and I gave you an example of each one. And we're going to fill in those little blanks in between the excluded x values and then the domain, how to write it. So you have your polynomial functions, you have a rational function, and then you have a, that's supposed to be radical, not rational. Change that last one to radical, not rational. So again, when we're asked for the domain, the two things that we talked about just a couple seconds ago was fractions. We're not allowed to have zero in the bottom of a fraction. And then radicals, specifically square roots or any even roots, you cannot have negative numbers under your radicals. So with that first polynomial function, and the example would be f of x equals x to the third minus 4x squared. Do I have a fraction there? No. Do I have a radical there? No. So what that means is if there is no fraction for me to get zero in the bottom of the denominator, or if there is no radical for me to get a negative number under it, then there are no restrictions to my domain. Okay, no excluded values. Which means if I solve for x, anything is a possibility. How do we say any number? All real numbers, but we're going to be writing these in interval notation. Remember with negative infinity and positive infinity, we've done that before. So if I'm saying that my domain can be anything, I mean, it could be any real number. So for me to write it, I'm just going to write it in interval notation. So it would be from negative infinity to positive infinity. And remember, we put parentheses with the infinities because you cannot actually equal. In my rational functions, g of x equals 2 over x squared minus 9. Again, this is just one example. But my restriction or my excluded x values would be what values, 1 or 2, make the denominator equal 0. Okay. So my excluded x values, anytime I have a fraction as a function, I'm looking at what values make that denominator turn 0. My domain would be anything besides those values, and we'll talk about how to do that in just a second once everybody has a minute to catch up. So let's look at that denominator there, x squared minus 9. I'm going to come down below here, or let's go to the side. Okay, again, we're focusing on the denominator only because that's the only part that cannot be 0. So if I wanted to figure out what values make that turn to 0, I'm just going to take it and set it equal to 0 and solve. So you may be able to look at it and tell what values would I plug into x to have it equal 0. And there's a couple of different ways we can solve these. But the easiest way would be to do this. So I'm going to add my 9 over. Now think about it. What number can I square that is equal to 9? 3. Is there another number that I can square that would equal 9? Negative 3. Okay. So if I were to finish solving this equation, we would take the square root. And anytime we take the square root of both sides of our equation, we have to put both options, the positive and the negative 3. Now, that's not my answer. My answer is not 3 and negative 3. That's what gives me an undefined value. So I have to say basically every number with the exception of 3 and negative 3. Okay? So this is how we're going to write it. Think about your number line. These are the two values that we cannot equal. What is the furthest number out here to the left? Negative infinity. Okay. And then what's the furthest number to the right? Positive infinity. So basically, we can have everything up to negative 3. So the first part of my domain is going to be parentheses, negative infinity to negative 3. I cannot equal negative 3, so I'm still using parentheses here. So that represents this portion, okay? But we can't equal that, so we're going to leave that open. And then I could have anything in between negative 3 and positive 3. So all of that. So I would have another piece to this domain. I would put my little union symbol here. And then it's going to be from negative 3 to positive 3. And again, parentheses on both, because I cannot equal those. If I equal those, that's what turns my denominator to 0. Is there still another section that is also included? Yes. Okay, so now I need to think about how to represent this. It's going to go from 3 all the way to positive infinity. So I'm going to put another union symbol. And this time I'm going to pick up at 3 and then all the way to positive infinity. And again, all of those have parentheses because we're not allowed to equal those values because that would give me a 0 in the bottom of my fraction. And that is how you would write your domain there. Okay. That is every real number with the exception of negative 3 and positive 3. And that's what our interval notation looks like to be able to say that. Everybody kind of okay there? Yeah. Okay. All right. Let's look at our radical functions. My h of x is equal to the square root of x minus 5. The only thing I cannot have here is a negative number under the radical. Okay, I can't have a negative value under the radical, otherwise that gives me an imaginary number. And domain is looking for what x could be if I want real numbers. So if I can't have that stuff under the radical, that x minus 5, okay, that's all I'm focused on right now is this part right here. If that cannot be negative, how would I write that to be able to give myself a range or a value of numbers? I need to solve that for x, but that x minus 5, it can't be negative. So I would have to write it as an inequality and say that it has to be greater than what? 0, okay. Can it be equal to 0? Can we take the square root of 0? Yeah, okay. What is the square root of 0? 0. So what I do in this case is I take that stuff that's under the radical, that x minus 5. Let me get a pen. Hold on. And I'm going to put it greater than or equal to 0. That means it has to be anything bigger than 0, but it also can equal 0. And then I would solve that for x, just like a regular equation. So that tells me that x is going to have to be greater than or equal to 5. Okay, so again, if we need the number line to help us, you don't have to draw these number lines if you know how to write your interval notation. Okay, but here's my 5. If I need to be greater than or equal to, first of all, that would be closed, right? Which direction is greater than? To the right. So how would I write everything, including 5, all the way to the right? What's my smallest value here? 5. Okay. Am I going to use a parenthesis or a bracket? Bracket, because it can actually equal 5. And then it's going to go comma all the way to positive infinity, and then that would be a parenthesis. So that is how I would write my domain there. So again, basically when you're asked for the domain, look at your function. If there is no fraction and no radical that has an even index, like square root or fourth root, then your answer is just going to be all real numbers for your domain, and you would write it as negative infinity to positive infinity. If it has a fraction, you've got to find out what makes that denominator equal 0, and your domain is everything but that number or those numbers if there are multiple. And then if you have a square root or a fourth root or any even radical, it's going to be everything that is greater than or equal to 0 in majority of the cases. I'll talk to you about when it's not that. But does that make a little bit of sense, kind of, sort of? Okay. All right. So we are told to find the domain of the given function, and we are expressing it in interval notation, which is what we just looked at in that little chart there. All right, with number 1, f of x is equal to 3 over x squared minus 25. Do I have either a fraction or an even radical? I do. So I have a fraction, which means I cannot get whatever numbers make that denominator turn to 0. So we're going to start by, again, focusing on the denominator only. We're going to figure out what values make x squared minus 25 equal to 0. And I know some of y'all can probably look at it and tell at this point. But just like the other one, in order to solve it, we're going to get x squared by itself. And then we're going to take the square root. But again, because I'm solving an equation, I have to think about both options, the positive and negative. What is the square root of 25? 5. So my domain can be everything with the exception of 5 and negative 5. So kind of like this one that we wrote up here, except for this time it's not 3 and negative 3. It's negative 5 and positive 5. So we got to represent this first part. What would this first interval look like? Okay, with parentheses, right? So negative infinity to negative 5. But I have another section, so I'm going to put my union there. Then I need to write this middle section, which would be from negative 5 to 5. And again, we're using parentheses because we cannot equal 5 or negative 5. And then I also need this last little interval here from 5 to positive infinity. So that would be the domain for that function there. Only if it helps you to write your intervals. Remember when you're writing your intervals, the smallest number always goes on the left. So when you're thinking that, you don't have to draw these number lines. If it helps you to write it, that's fine. But just remember with its fractions, whatever gives you 0 is going to be from negative infinity to that number, and then make up the rest of it. Sometimes you'll have 2 of them. Sometimes you'll only have 1. All right, ready? Kind of understand a little bit? Right. So, number 2, I have h of x is equal to, this is the 4th root of 9x minus 2. Am I allowed to have a negative under a 4th root? No, just like we can't have it under a square root. Any even root, anytime your index is even, we cannot have that negative value. So, we're going to take everything under the radical. And I need it to be positive. Could it also be 0 though? Yep, so we're going to set it, what's the inequality? 9x minus 2 is greater than or equal to 0. So if you want to solve that for x, then we can focus on how to write the interval notation. Greater than or equal to 2 over 9. So if you need the number line, that's what it would look like. So how would that interval notation look like? Bracket or parenthesis? Bracket, and then what? 2 over 9, comma, all the way to infinity, and then a parenthesis. So that would be your domain for that one. Again, the only 2 times that you're going to have restrictions is if you have a fraction that has a variable in the denominator, or you have an even radical, a square root, a 4th root, a 6th root. Any of those you cannot have. Other than that, your domain will be all real numbers, which is negative infinity to positive infinity. Any questions so far? Try those 2. I'm going to try to on number 3. Because if it's a square root or so it's only here is greater than Be careful with 3. It's true. Quick question while some of you are working. Why do we think 3 might be a trick? It's not even. What kind of index am I finding? What kind of root am I finding there? A cube root. Are you allowed to have negatives under cube roots? Yeah. So would there be any restrictions if it's a cube root? Yeah. That might answer some of your questions. Did that answer your question? Okay, so if you're using a radical, it's going to be greater than, because you can't have this. Right? So in order to have Or you can't ever have a negative under even. This one is an R index. It would be all real numbers, so that would be the negative and then the
Sometimes they're dramatic. Like you can tell she flaws. She knows how to
there are infinity. All right, so with number 3, if it is a cube root and I can have negatives under there, would there be any restrictions for this one? No. So my domain is going to be all real numbers, which in interval notation is parenthesis, negative infinity to positive infinity, parenthesis. Okay. I didn't have a fraction and I did not have an even root, meaning a square root or a fourth root. What about 4? Do I have a fraction? No. Do I have a radical? No. So are there any restrictions on that one? No. So again, this one is a relatively simple one. It is all real numbers. X can be anything because I don't have a fraction and I don't have an even index radical. Try those two. Square root. Like this one has a fraction, this one has a fourth root. So those two would have restrictions. Because you can't have 0 here and you can't have another here. So since I didn't have a fraction or a radical, there are no restrictions. X could be anything. So what do I have in number 5? A radical, which can't be negative. So what we're going to do, again, to figure out what our values are, is we're going to take that stuff under the radical. It can't be negative, which means it has to be positive, but it can also be 0. So we're going to put greater than or equal to 0. We're going to add 3. And so what this says is my domain is going to be everything that is greater than or equal to 3. But I need to write that in interval notation. Smallest number goes on the left. What's smaller, 3 or everything bigger than 3? 3. And I'm going to put a bracket or parenthesis. Bracket. And then it's going to go forever to the right. So that is going to be to infinity. And what do I have in number 6? A fraction, which I cannot have 0 in the bottom. So again, we just take that. If you can't look at it and tell, you can take it, set it equal to 0, and solve for x. Those will be the values that you cannot have. Your domain would be everything else. What are the two numbers that I can square to get 4? 2 and -2. All right, so again, kind of think about it like this. It's everything except for -2 and +2. So what would I write? Start with a parenthesis or bracket. Parenthesis and then -infinity to -2. Parenthesis, then union, and then what? -2 to 2. All right, and then the last one? There you go. Okay, so everything with the exception of 2 and -2. Again, the smallest number always goes on the left in your interval notation. Think about your number line. We always read from left to right, so small goes first. Anybody have any questions? I got one more. Very similar to a couple that we've already done. Also, there's one little slight difference here. I want to see if we pick up on it. Fraction or even radical? Even radical. So that means the stuff under it cannot equal what? What kind of numbers? Negatives. Okay. So I'm going to take that 10 minus 5x and I'm going to set it greater than or equal to 0. Okay, now we've got to solve here so we can find out what our value is. And this is where the little difference comes in. What do I have to divide by? And when you use an inequality and you divide by a negative number, what is it you have to do to that inequality? You have to flip it. So it becomes x is less than or equal to, what's -10 divided by -5? 2. How do I write that? What comes first? -infinity all the way to 2 with a bracket. Okay. We still set it greater than or equal to 0. It was just in the process of solving for x so that we can get our restricted values that we ended up having to flip that inequality, okay? So anytime you have an even radical, you're going to take that stuff under the radical, you're going to set it greater than or equal to 0, always. The only time it would not be equal to 0 is if, let's say, I did this. Okay, I'm going to use the same one that we did for number 5, I think it was. This one, it would have to be a positive number, but why can't it equal 0? Because it's where? In the bottom of a fraction. So just be careful with that. If you ever get one of those with a radical in the bottom of a fraction, then you would not include the equal to. But other than that, anytime you have an even index radical,